Here, let me look it up. So somebody want to know how many questions the test is going to have? Let's look it up. This one. All right, so for test number 3, yeah, so we're gonna have 39. And for test, well, sorry, not test number 3, test number 1. Test number 1 is gonna have 39 questions, but kind of don't get afraid of how many questions it is, because essentially each question is an independent part. So what that means, it just means that there's one question only gonna ask you to do one thing. So say like if I want you to find the 5-number summary, if I want you to find the 5-number summary, there are going to be 5 questions for each one of those numbers. So one of them is going to ask you, what is the minimum? One of them is going to ask you, what is quartile 1? What is one of them going to be, what is my median? So yeah, it does seem like a lot of questions, but I just broke it down where each question is asking one thing. So that way I know if you are able to recognize that one thing. And also, yes, now some of them are definition questions. So like, is this a continuous data set? Is this a discrete data set? So I'm hoping that those problems, you could do it like in less than a minute, because all you have to do is just read the problem and you see, is it a discrete data set? Is it a continuous data set? So those problems, you should be able to kind of speed through those. All right, but yeah, so for exam number 1, you should have 39 questions. Yeah, so there are going to be some question where you have to submit a picture, but like I said, for the picture, if you feel like it's going to take a long time, take the picture, save it, and then as soon as you're done with the test, email me those pictures, for that way I know that you did it. You didn't take an extra hour or 2 hour to do those questions. So as soon as you're done with the exam, uh, you have to email me those pictures, so that way I know that you didn't kind of keep working on it after the exam. So there are going to be some questions where I ask you to upload it, because say like if I ask you to draw like a histogram or a dot plot or or a box plot, it's kind of hard to draw that on Canvas, or kind of hard to make up a question where you could draw that on Canvas. So unfortunately, like you are going to need to upload those questions. And for the exam, I actually increased the time from 75 minutes to 90 minutes. So you roughly have probably, like, you should have a good amount of time to be able to do all of the questions. But that is if you kind of know what each question is asking for. If you're going to have to be looking through definition and problem or example through for all the problem, that's going to take up a lot of time. So like as soon as I say find the mean or find the median or find standard deviation, you should kind of already know how to find that, and you want to use your notes for kind of confirmation on how to do that. But like you should have enough time to be able to do that. Any question? Let's see for today quiz. Well, for today quiz, I was actually just planning on going over it, so we'll go over it today, so that way you can see what you did right, what you did wrong. For that way, for the test, if those type of questions are on the test, you don't do those mistakes again. Any other question in regard to the test so far? Okay. All right. So we're gonna go ahead and finish up this chapter. So we're gonna finish up chapter 3. Like, there's nothing new we're gonna really learn from chapter 3, only about the distribution. But hopefully, you could already know the distribution. So we're going to go over symmetric, left skew, and right skew. So let's move this over here. All right, so if you look at the first drawing right here, so here's a box plot. So by looking at a box plot, you can kind of tell the distribution of that box plot. So if you look at the first one I put that this is symmetric. Cool. So if you look at it, it's symmetric because if you look at both of these tails over here, are they the same length or they're approximately the same length? Oh, sorry, are they different length or are they pretty close to the same length? So if you want, you can put in the chat, or if you want, just vocalize your answer. Cool, yeah. So they're about the same. So whenever we have both of our data set or both of our whisker, if both of them are approximately the same, you say it's symmetric. What about this one over here? If you look at this one, I already told you it's skewed to the left. So for this one, what do we notice about both of the tails? Are both of the tails the same length or are they pretty much different? Yeah, they're different. If you look at both tail, which tail have the longer tail? Cool. And that's why it's a left skew, because the left side is the longer one. All right. And then if you look at the very last one, this one says skew to the right. Because if I look at both tail, which tail have the longer tail, the left side or the right side? All right, good, perfect. So if you look at it, the right side have the longer tail, so this would be called a right skew. So that's how you can tell the distribution and tell the shape of a distribution just by looking at a box plot. So depending on the tail, that's kind of going to tell you if it's left skew, right skew, or symmetric. The one thing that kind of add an extra wrinkle to this, if you have an outlier. So if you have an outlier, that means that's an extreme value. So if you do have an outlier, pretty much 99% of the time, wherever the outlier is at, that's which side going to be skewed. So if you have outlier on the right side, it's most likely going to be skewed to the right. But if you have outlier to the left side, then most likely it's going to be skewed to the left. All right. Everybody good with that? All right. So what we're going to go ahead and do, we're going to go back to some of the problem that we already did a box plot. And we're kind of going to say if it's skewed to the left, skewed to the right, or if it's symmetric. So let's look at this box plot. So for this box plot, what do you think should be the distribution? Should I say symmetric? Should I say skewed to the left? Or should I say skewed to the right? Well, if you look at this one, do we have outliers? So we have these outliers. And these outliers essentially are pushing it away. So since we have the outlier to the right side, this one you actually should say skew right. Because hypothetically, if there were no outliers in this one, then we could say symmetric. But once we add those outliers, it essentially make it skew to the right. So you can't just ignore the outlier. You have to kind of input the outlier into that scenario. So for this one, oops. So yeah, so the outlier make the skew to the right. So let's go up more. What about this one? Which distribution should I say this one has? Should I say skew to the left, skew to the right? All right, perfect. So this is left skew. Good job. All right. Actually, let me go back because there's some two questions that I kind of didn't answer, and let me just answer those right now. So one of them is if there's an outlier, is always to the right. No. So the outlier could be to the left side. Because if you kind of look at this one an outlier too, and it's to the left hand side. So the outlier is not always going to be on the left side or the right side. It could be on either one of those sides. So if the outlier is on the left side, it's left skew. If the outlier on the right side is right skew. If you actually have an outlier on the left side and on the right side, then it will probably be symmetric. All right, and then there was one more question I think that I saw. Okay, so the other question was, so if there were no outlier, it will be symmetric, correct? Yeah, if hypothetically, if we were to take away those outlier and yes, we get that one box plot, that box plot will be considered symmetric because if you look at both of the tail roughly look the same size. So we would say that it's symmetric. Yeah, I think that was the only other box plot we did. All right, let's do this last box plot. So for this last box plot, which distribution should I say it is? All right, so we already got the skew, good job. And we said skew left, perfect. All right. So that's how you want to use the box plot and you'll be able to see if your distribution should be skewed to the left, skewed to the right, or symmetric. All right. And that was pretty much the last thing that we were going to learn for chapter 3. Any question in regard to chapter 3? All right. So the last thing we're going to go ahead and do is essentially going to be kind of a combination of like chapter number 1, chapter number 3. So let's get to the last question. Perfect. All right. So for this one, it says the table below contains 78 students score from a communication test. Each score is from a unique student. Please work with a partner and select a simple random sample of 20 score. Okay, so for this one, you're not gonna work in partner because you can't really partner up right now. So we're gonna just ignore that. So what we're gonna do right now, or what you're gonna do right now, I want you to randomly select 20, 20 scores. So what I mean about that, I'm gonna show you how to randomly select 20 scores. So let's see this. All right, so hopefully by now you have a TI emulator on your Android or your Apple, or if you have the TI 83 or 84, just use it. All right, so what we want to do, let me actually go back to here. So if you look at this one, how big of a population size do we have? Yeah, 78, perfect. So we have a population of 78, and what we want to do, we want to randomly select 20 scores. So that means each one of these scores, we want to just randomly select 20 scores. So we really don't want to use our intuition of what a random is. So what we're going to do, we're going to let the calculator randomly choose it for us. So what we're going to do, we're going to just number each one of these. So say for 111, we're going to say that's number 1. 107, that's 2. So when I randomly select a number, I'm going to randomly select a number from 1 all the way to 78. And if that number is 1, that means I randomly choose 111. If that number, say, is 78, I choose number 78. So what I'm going to do, I'm going to show you how to do that on your calculator on the TI-84. Everybody kind of good on what we're doing right now? All right. All right. So on your TI-84, what you should see, if you look at the alpha button, which is very green on my button, right below it, it says map. So I want you to hit the map button. Up next, what I want you to do, if you look at it on the top, it says cancel, map, num, CPX, and PRB. So what I want you to do, I want you to go over where it says PRB. All right. Everybody go with PRB. All right. So if you look right now, if you look at mine is at number 5. It says ran int. So that means we're gonna randomly select the integer. So let's do this. So I selected random int. So what I want to do, I want to tell them what the lowest number, what the highest number. So for this one, what should be the lowest number if we want it to be from 1 to 78? All right, so the lowest number should be 1. What should be the highest number? Very good. We're on it today. All right. All right, everybody go while we put 1 through 78. Okay, so up next, what I'm going to do, I'm going to press enter. So if you look at this one, it chose number 66. So that means I have to go to test score number 66. So I'm going to go ahead and transfer over back to my notes. So this is test score number 1, 2, 3, 4, 5, 6, 7, 8. All right. Oh, cool. Yeah, thanks for helping out the other student. All right, so if you look at it, so I chose 66, but if I got random integer 66, that doesn't mean that you got the random integer 66, because this should be random. So if I got 66, hopefully none of you got 66. So that means I randomly select that first person. So 66 was 105. So that's my first sample. So now what I have to go ahead and do, I'm going to go ahead and do this again. So the good thing, once you already enter it, all you have to do is press enter again. And it'll give you another random number. So now I'm getting 31. So let's get 31. All right. So now what I'm going to do, I'm going to get other random number until I actually get to 20. Everybody good on kind of like the concept of what we're doing right now? All right. So what I want you to do, I want you to get your 20 numbers. So your 20 numbers should be vastly different from other people's 20 numbers. So take a minute and get your 20 numbers. If you have one number that repeated, you essentially just ignore that number because essentially what you want, we want non-identical test score. So if you do get a random number that repeat again, you just ignore that number and you just keep on going until you get 20 new random number. So, so 1, 2, 3, 4, 5, 6, 7. All right, so I got my 20 number. And if you kind of look at it, they're kind of all random. They're not like all in one place. They're pretty much all over the place. So that's like why you want to do a simple random sampling, because a simple random sampling will kind of guarantee that all of the outcome has an equal chance. Because when we're doing the random int in the TI-84, pretty much everything has an equal chance of occurring. So the first test score all the way to the 78 test score, all of them have the 1 in 78 chance of occurring. Everybody good? How many people still need a little bit more time for randomly selecting the 20 number? If you still need more time, you put yes on the chat board, or you say yes. All right. Cool. So that's all you have to do for A. So what I want you to do for B, I want you to get the 20 number that you got, and I want you to find the average of those 20 number. So take a minute and look at your 20 number and find the average of those 20 number. So theoretically, oops, you could do 111 plus 114. All right, so those are all of my numbers that I have to still add. And then what you want to do, you divide it by however many numbers we have. Since I randomly selected 20 number, this should be 20. So let me take a minute and let me do that right now. Cool. All right. So when I found my mean, I got 108.5. So when you find your mean, what I want you to do, I want you just to post it on the chat. So let me put some of the mean that I'm getting from the chat. So we go 108.6. 99.3, 98.7, 108.65. Sorry about that. All right. So let's look at all of these means. So do we have any means that repeated? Like, did anybody get exactly the same mean as anybody else? Yeah, so if you kind of look at it, nobody got the same mean. So everybody mean was completely different because this is a random sample for everybody. But if we look at it, kind of, if you look at the data set, where are most of the mean in between? Like, where do we have a good chunk of the data set at? Yeah, so if you kind of look at it, like, all these numbers are relatively close to each other. So all of those numbers are relatively close to each other. And then we also have this other group of pretty much just like the high 100. They're pretty close to it. So what this kind of telling us, it doesn't matter like if we have the same population, depending on what's our sample is, it could drastically change because not everybody gonna get exactly the same thing. Not everybody gonna get the same mean. We're all gonna get a different mean, but we kind of want to look at what are the similarities that we have. So, but also we have this one over here. For this one, if you look at it, it's kind of low for our data set, especially if you look at our data set, there's nobody who scored in the 40. So this might be considered an outlier. Because this data set doesn't really click with all the other data sets. Because all the other data sets between like 106 and 110 and 6 to 99.8. But if you look at this one, this is pretty far away from both of those little side grouping. So what we're gonna do right now, we're gonna actually go ahead and find the mean of the population because we kind of want to see how close were we. So I'm not gonna make you find the mean of the population for the 78. For this one, I actually already got it in my calculator. So that way, you don't have to worry about it. All right, so in my calculator, let me turn on the calculator. In my calculator, I already entered the data set here. So I already entered the data set here. So I enter all 78 of the data set. And what I want to do, I want to find the mean of that data set. So if I want to find the mean of the data set, I'm going to go to stats. I'm going to go over to calculate. And I'm going to do the 1 bar stats. So list is L1. Frequency, leave it blank. Calculate, we shall. All right. So if you look at my mean, what was my mean of this problem? And the answer is right there. All you have to do is look at it. Perfect. But for this one, if you look at it, it says X bar. What do I have to change about that X bar? What should I change it to? Like, which symbol should I use instead of X bar? Start with an M. And it's a Greek letter. Well, X bar is the mean, but remember, X bar is the sample mean. What is the symbol for the population mean?
Mu?
Mu, perfect, yeah. So we want to say mu is equal to 108.923, whatever. All right, good. All right. So if you look at the calculator, you could get all these other goodies underneath. So if you want to find number summary, you got the find number summary of 72, 103, 110, 118, 136. But for this problem, all we care about is our mean. So we're done with the mean. All right. Any question in regards to that? All right then. So let me go back to my notes. All right. So if you look at, this is the mean of the population. So that's my mean of the population. So the mean test score for this communication test was 108.923. So when I took my sample, were any of my sample close or were they all pretty much far away from it? Like how many sample means do we have that are kind of close to it? Or you would consider close to it? Here, let me label this. So we'll say this is our first mean, second mean, third mean, fourth mean, fifth mean, 6, 7, 8, 9, 10, 11, 12. All right. How many people would say that our first mean that we got of 108.5 is close? So you put yes for it is close or no, it's not close. All right, so we'll say yes. What about our second mean of 108.6? Is that close or is that pretty far away? What about 99.3? Was that close or is that pretty far away? No, so we'll put no. What about 98.7? Well, that close. Yeah, so we'll put no. So what about 108.65? Cool. All right, so yeah, unanimous, yeah. What about 110.95? All right, very picky over here. No. What about 109.25? All right, so you got a yes. What about 107.25? What about 99.8? No. What about 96.4? Neat. What about 107.45? What about 43.1? Cool. Hello, that one, that one. All right, so if you kind of look at it, like our sample, most of our sample were pretty close to it. Like we had 1, 2, 3, 4, 5, 6. So we have 6 that we say yes, it was pretty close, and then we had 1, 2, 3, 4, 5, 6. 6 that we say no. So that's what's important about a sample, because just by getting a sample, you could get pretty close to what the population mean is. Because we found that the population mean was 108. But if you look at most of our sample actually gave us a pretty good reading on it. Like I still think this one should be probably a yes, because it's still pretty close to it. But if you look at most of the sample, they gave us a kind of a good, accurate answer of what it should be. So that's why it's important that you always have a simple random sample. Because if you have a simple random sample, usually any information that we extract from that should give us some information about the mean. All right. But that's it for that pretty much activity. Any question for this activity? All right, so we are officially done with chapter 3. So let's see. All right, so let me go over the quiz. So that way you could kind of see what mistake you made or how perfect your quiz was. All right, so that's the test. We don't want to see that. So, all right, quiz number 3. And also remember, if you cannot take quiz, well, not quiz, sorry. If you can't take test number 1 on Monday from 7 a.m. to 7 p.m., please let me know by Thursday what other day you could kind of possibly make it, and give me like a 2-hour gap period. So that way I could open it up for you for that 2-hour window. So if you know you cannot make it to that test from 7 a.m. to 7 p.m., if you can have a 2-hour window in between that window, please let me know for that way I can make that accommodation, because once the test is done, the test is done. So, all right, so this is the first question. So actually what I'll do, I'll just go back and from here. All right. So if you look right here, it says the life expectancy for a person is 71 years with a standard deviation of 5 years. If a person lived to be 84, what will be the z-score for this person? So right here, they're telling us the life expectancy for the person is 71 years, so they're telling us their average age. So we know 71 is our mean, and we know standard deviation is 5. And we want to know what the z-score for somebody who lived 84 years. So for this one, What we want to do, you want to do 84 minus 71, and then you divide it by our standard deviation, which is 5. So if you look right here, you get 2.6, and that's the answer, 2.6. Any question for question number 1? All right, on to question number 2. All right, so for question number 2, it says, if a z-score is negative, what does that mean about the x value? So if your z-score is negative, it means that the x value is below the average. So you say x is below the average. For the most case, everybody got this one right if you answer. The only one that I gave partial credits, some people said that it had to be 2 standard deviations below the average, which is kind of right, but not right, because it doesn't have to be 2 standard deviation. It could be like 1 standard deviation, half of a standard deviation, a quarter of a standard deviation. So if you did put that, I gave you, I think, 2 points or something like that. All right, but that's it for question number 2. Any question in regard to this problem? All right, let's do question number 3. All right, so question number 3 is the top one right here. It says, if student A was 2.35 z-score and student B z-score on the same test was 1.76, who did relatively better on this test? So student A got a z-score of 2.35, student B got a z-score of 1.76. So for this one, it will be student A, since 2.35 is bigger, not bigger, bigger than 1.76. And that's all you have to do for that one. So you have to just know the higher your z-score is, the better of relative standing that person has. So the smaller that z-score is, the less of a relative standing that person has. But that's it for 3. Any question in regard to 3? All right, on to 4. All right, so 4, it says the IQ score have a mean of 100 and a standard deviation of 16. Elon Musk reportedly had an IQ of 155. Convert Elon Musk's IQ score to a z-score. And if you look right here, it says round answer to 2 decimal places. So that was important. Some of you I saw didn't get that problem right because you didn't round the answer to 2 decimal places. You rounded it to like 1 decimal place or something like that. So do practice on just knowing your decimal places, like 1 decimal place, 2 decimal place, 3 decimal places, because on the test, that will kill you if you don't know the decimal places. All right, so let me go over here. So once again, you'll say 155 minus 100, and then just divide this, oops, that's not the division sign, by 16. So if you look at, you get 3.4375. You use the 7 to round up this 3, so you get 3.44. So you get 3.44. And that's all you had to do for question number 4. Any question in regard to question number 4? All right, last one. All right, so for this one, said IQ score have a mean of 100 and a standard deviation of 16. Elon Musk reporting had a IQ of 155. If we consider usual IQ score to be those that converge z-score between -2 and 2, is Elon Musk IQ usual or unusual? So this is telling you a z-score of -2 to +2 is considered to be usual. So if something is above 2 or lower -2, it's considered unusual. So for this one, since Elon Musk's z-score was 3.44, this would be considered unusual. And that was question number 5. So that's all you had to do. Just know that Elon Musk's z-score was 3.44. Since 3.44 is greater than 2, you want to put that is unusual. And that was today's quiz. All right. Any question in regard to today's quiz? All right. So, like one advice I would give you for the test, whatever answer you got for the previous, you do kind of want to write it down in case you're gonna need it for the next one. So, yes, always have everything written down so that way, if you do need something from the previous, you do already have it. So, just have your scratch work ready because I don't want you to just solve something and then go to the next one and then you have to solve another thing using the information you got for the last one. So do keep everything written down and organized so that way if you do need that information, you already have it and that way you don't have to solve that problem again. All right, but that's it for the quiz. So let's see. Let's see what I have for the study guide. So what I'm gonna do, I'm gonna go through the study guide and just let me know if you have any question about that topic. So we'll start off at chapter 1 and we'll work our way up to chapter 3. So from oldest to newest. No, you should have gotten the same question for all of them. Like for all of them, I gave the same question. No, if you didn't add the 3.44, I'm assuming you're talking about question number 5. It still should be correct. If you didn't put unusual, it will be incorrect. So if I did make that mistake, you let me know and I'll go back and look at it. But usually if you put unusual, I gave you credit. But if you put usual, I didn't give you credit because that's incorrect. Oh, yes. Let's see. Quiz. Yes. All right, cool. So you should be able to see your quiz and whatnot. And also, I had a student ask me if they could do test correction on quizzes. Well, the answer for that is no, because the test is different from a quiz. For the quizzes, I dropped, well, essentially I keep the highest 8 quizzes. So if you do good on all of your quizzes, I drop the lowest 2 quizzes. So that's how I'm gonna take care of that. So that way I'm not gonna do test correction for quizzes because quizzes are not tests. The test correction are only 4 tests for that for those 3 chapters. All right. So let's see. Anybody have a question about observational study or a experiment? All right, now, what about quantitative versus qualitative? One, two. All right, now, what about discrete versus continuous? One, two, three, four. What about parameter versus statistic, or parameter or statistic? All right, what about sampling distribution? All right, what about population of interest? All right, good. All right, no question for chapter 1. Perfect. All right, what about question for chapter 2? So pretty much this is just know how to read and construct a histogram, bar graph, pie chart, stem and leaf, and dot plot. So you should either know how to read them or know how to construct that. So if I give you a histogram, or if I give you a, what you call it, a stem and leaf plot, if I give you a pie chart or a bar graph, you should be able to read it. So if I tell you how many people fall into this category, or how many people score higher than 70 or lower than 70, you should be able to read the histogram or the pie chart or the stem and leaf plot to be able to give me an answer. So any question in regard to anything chapter 2? Cool. Stem and leaf plot. All right, so let me transition over to my notes. So this is stem and leaf. All right, give it a minute, because I haven't loaded everything. No, let's do this. Let's stop the share and let's reshare this. All right. So here goes the stem and leaf plot. So hopefully it shouldn't give you that much trouble. So here's the stem. Oh, steam. No. There you. All right. So there's your stem and leaf plot. So first thing you always want to do is look at the stem and leaf plot and just look at what the lowest number is. So the lowest number in this case is what? 14. Perfect. And then you want to just look at what the highest number. Well, the highest number is 31. So if you look at it, the lowest number is 14. The highest number we have is 31. So we have numbered in the 10th place, and we have numbered in the 30s. So that means the stem is going to start at 1, because that represents the stem. Oh, sorry, it represents the tens, and go to the 20s and to the 30s. All right. So then what you want to go ahead and do is just go ahead and look at how many numbers are in the tens. So all of these numbers. So you get 14, which you put 4. You get 17, which you put 7. And you get 19, which you put 9. And those are my leaf for stem of 1. Any question in regard to that first one? All right. Then you want to look at your 20. So 20, you have 21, 23, 28, 29. And that's it for 20. And then 30 will be 31. All right. And that's your stem and leaf plot. Any question in regards to the stem and leaf plot? Double? No. Yeah, we're not going to double it up. Maybe if it was a breeding test, but not a canvas test. Okay. So say for this stem and leaf plot, what type of distribution would you say this stem and leaf plot had? If it's skewed to the left, skewed to the right, or is it symmetric? Yeah, if you look at this one, you could say skewed to the right, but you could also say symmetric. Yeah, so you could say skewed to the right for this one, because if you look at a majority of the data set in the beginning, and then kind of like taper off. But yeah, but that's it for chapter 2. So you have to know how to read the graph. Like reading the graph, hopefully shouldn't be that hard for you because pretty much you just look at the graph and you're seeing what numbers are there. Okay, I don't know which number 6 you're talking about because there's section 1.1, 1.2, 1.3. So guys, give me some hints on which section it is. Any other question in regard to the stem and leaf plot? All right, that was chapter 2. Let me see. Oh, population of interest. Population of interest, just being able to identify what's the population. So, like if you go to, let's see, chapter 1, page number 16. If you look at this question B, this will be a good example for population of interest because it's asking what is the population for which this study applied to. So this will be freshman English students. So you'll be able to tell me who does this study belong to, or who can we get this data set and who can we make a conclusion about. So for this one, the population of interest is freshman English students because it only applied to them. All right. All right. So that should be good for chapter 1 and good for chapter 2. All right. So let me go back to. All right. So I guess we get some requests for population standard deviation. So let's see. All right, cool. So let's do some example for population standard deviation. So do you have a question about dot plot? Let's see. Does anybody want me to go over dot plot, or how do we feel about dot plot? If you want me to go over dot plot, I'll go over dot plot. Well, same thing like the histogram, like the histogram stem and plot. You should be able to know how to construct the dot plot. If I ask you to like construct the dot plot and upload a picture of constructing a dot plot, and you should be able to read the dot plot, kind of like the example that I did in class was about the dot plot that we created for the Ben and Jerry calories. How we created a dot plot with that data set, but also how we were able to see like how many of those dot plots had a calorie of 300 or more. So you should be able to, yeah, so let me show you that example. Chapter 2, I think I skipped it. I don't know if this is how to do it badly. So yeah, so that was the example I did in class. So A, you should know how to construct a dot plot. But if I were to give you a dot plot constructed, you should be able to read it and be able to answer like some simple question, like this one question, like how many ice cream do we have that had 300 or more calories? Well, we said it was all of these. So we say a frequency of 10. Or if I asked you to find the percentage of ice cream that had 300 or more calories, we did 10 divided by 36. So that's what I mean about the dot plot. You should know how to construct the dot plot, but also you should know how to read the dot plot. Any further question in regard to dot plot? Perfect. All right, so let's go back to standard deviation. All right, so for standard deviation, let me make up some numbers. So I'll say this is an example. We'll say this is a sample. And we'll say this sample is cool. All right, so say that's our data set, and I tell you this is a sample. So since I tell you this is a sample, you want to use the formula S is equal to square root of the summation of x minus mu, x minus mean squared divided by n minus 1. Like the reason I know I'm using this formula because they told me this is a sample, so it's a sample standard deviation. In the test, it's not going to be that straightforward. You're going to have to be able to read the sentence and be able to see from that sentence, is that a sample or is that a population? A good way to kind of know if it's a sample or a population. A sample, they will always tell you they took a random selection. So if I tell you, hey, I took a random selection and this is my data set, that's a sample. If I tell you I collected all the data set, that's a population. So you kind of want to be able to read the sentence to be able to distinguish if it's a sample or if it's a population. Sample will be, I tell you, we randomly selected so many people or so many objects. A population will be, here's all the data set. Now find me the standard deviation. All right. So the first thing you always want to go ahead and do when you're finding the standard deviation, you first have to find the mean. So to find the mean, all we're going to do, we're going to add up all these numbers. And you divide it by however many numbers we have. So if you look at this one, you have 5 numbers. So you divide it by 5. Everybody good so far? How we got 70 plus 68 plus 72 plus 60 plus 80? Cool. Thanks, Nicole. All right. So Nicole gave us the answer. We got 70. All right. Any question in regard to how I got that? All right. So let's do the table. All right. Everybody get so far on the table? All right. So I'm going to give you a little hint or big hint. On the test, you're going to have a table like this. And I'm going to tell you, fill all of this up. So you do want to know how to get these numbers, because for the test, I'm going to give you a table and you're going to have to know how to fill out all of these parts. So if you don't know how to fill out those parts, it's going to be very difficult. If you do know how to fill out those parts, it's going to be very easy because all you have to do is just follow the pretty much table. So say for the first one, you want to do 70 minus 70 and you get 0. But for your answer, just put this. I don't want you to put 70 minus 70 or whatever the mean and the x is, you put the final result. All right, so then let's go on to 68. So if you look at this one over here, we're going to do 68 minus 70. 68 minus 70 will give us what? -2, perfect. All right, so then if I do 72 minus 70, you get +2. If I do 60 minus 70, you get -10. If I do 80 minus 70, you get +10. So all you have to do for that portion, just know how to fill out that table. So it shouldn't be that bad as long as you have the correct mean. And for the mean, it will always be a whole number. So if you get a decimal answer for your mean, you're doing it wrong because the way I calculated the mean, it should give you a whole number just like I calculated this one. You should get a whole number. So that way you don't have to worry about decimal or anything like that. You just have to worry about knowing how to subtract integers. All right. So let's go on to the next one. So next one, you get these numbers and you square them. So we're going to do 0 to the second power is 0. -2 to the second power is 4. 2 to the second power is 4 again. -10 to the second power is 100. 10 to the second power is 100. So notice how for the last column, all of the numbers should be positive. If you put a negative or if you think about putting a negative, slap yourself and don't put the negative because it should always be positive. All right. Any question for the last column? All right. So lastly, all we have to do is add up these numbers. So if you do 0 plus 4 plus 4 plus 100 plus 100, what should we get? Let's do some mental math. Cool, perfect. 208. So you get 208. So last thing we're going to go ahead and do is go back to the formula. All right, so that's our formula. So all we have to do is do square root of the summation of x minus x bar to the second power, which is 208, divided by n minus 1. N in this case should be 5. They do 5 minus 1. All right. So say for this one, I tell you 3 decimal places. Oh, that's horrible. So if I tell you 3 decimal places, you give me 3 decimal places. So for this one, I'm going to do this in my calculator real quickly. So you do square root of 208 divided by 5 minus 1. You kind of want to do that in your head because that should be very simple. So 5 minus 1 is 4. Ooh. All right. Good job with the answer. Remember, 3 decimal places. So you get 7.211. And that's how you do sample standard deviation. If it's population standard deviation, there's nothing very different. The only thing that changed, instead of dividing by n minus 1, you divide by capital N, which is your population sample size. So it's nothing really different. Like say if this was a population, all that will happen, you just say square root of 208 divided by 5. So that's literally the only thing that's going to change. instead of dividing by 4, you get divide by 5. But like the process is still the same. It should be pretty simple. All right, but that's sample standard deviation and population standard deviation. Any question in regard to standard deviation or any follow-up question in regard to standard deviation? All right, so what I'm gonna go ahead and do, I'm gonna transfer back to the study guide so that way we could kind of just scroll down. All right. Any question in regard to empirical rule or Chebyshev rule? All right. Yeah. So on the test question, like if it is a numerical value, I'll tell you how many decimal places I want. Cool. All right. So when do we use Chebyshev rule and when do we use the empirical rule? All right. So when do we use the Chebyshev rule or when do we use the empirical rule? So for the empirical rule, let me transition back to the notes so that way you can kind of see it instead of just hearing my voice. All right, so let's do a new page. So we'll have empirical versus Chebyshev. All right. So when do we use the empirical rule? When do we use the Chebyshev rule? So when we use the empirical rule, we have to know our data set is either normal distribution or symmetric. So if I say the distribution is normal, or if I say it has a symmetric distribution, that's your clue to do the empirical rule. So that's how you know to do the empirical rule. If I'm telling you, because on the test, I'm going to tell you, you're going to either use the empirical rule or you're going to use the Chebyshev rule. It's up to you to decide which of the two rules you're going to use. So if you use the wrong rule, it's going to give you the wrong answer. So you want to be able to decide if you want to use the empirical rule, and the empirical rule, we use it when it has a normal distribution or when it's symmetric. You use the Chebyshev rule. You use the Chebyshev rule when our data set is not normal or not given. So if I tell you the distribution is skewed to the left or is skewed to the right, that's me telling you it's not normal. Or if I don't mention anything about the distribution, that's me pretty much telling you it's not normal. Because if I don't mention it, that means we don't know it's normal or we don't know it's not normal. So you just assume it's not normal. But that's how you know for the empirical rule, if it's the empirical rule in the problem, it should state if it has a normal distribution or if it's symmetric. If it's a Chebyshev rule, it should say it's not normal or they don't give you that information. Perfect. Cool. And also for these type of questions, yeah, so if I say skew left or skew right, it should be the Chebyshev rule. And for this problem, because I've been kind of telling you do approximately, and this one is at least. But for this one, just worry about getting the probability. Don't worry about approximately or at least. Like I know by the way that you answer the question if it's approximately or if it's at least. So you don't have to worry about putting approximately or at least. Just give me the actual percentage that you find. So if it's 95%, you put 0.95. If it's 75%, you give me 0.75. You do not have to put at least or approximately because it's a little bit too complicated to do that for Canvas. All right. But that's it for empirical versus the Chebyshev rule. And for this one, you are gonna have both of them. So you do kind of want to know how to do the both of them because you're gonna have two problems or at least two problems. That's one of them you have to use the empirical rule. The other one you're gonna have to use the Chebyshev rule, and it's up to you to decide which of the two you're gonna use it on. I'm not gonna tell you. You're gonna tell me, and I'll tell you if you're right or wrong. All right, let me see. Yeah. And you also know, like, for the book for some of them it does it a little bit differently than mine or than my way. So remember, who's writing the test? I'm writing the test. So you do the way that I taught you. So kind of going back to like the histogram quiz, where I tell you for the class width, we always round it up. So we always round it up, or for the classes, we always round it up. So always go based off of what my lecture notes says, because at the end of the day, I'm making it up. So even though the book does it a little bit different, do it the way that I did it because essentially I'm creating the test and I'm putting the answer. So the answer will be how I did it versus how the book is telling you to do it. Now for the exam, pretty much you're gonna go one at a time and you can't really skip the question. Like once you get to it, pretty much you have to answer it. Cool. All right. So any other follow-up question in regard to the empirical rule versus Chebyshev rule? So, like, if you're creating notes, you should have notes separately for empirical rule and Chebyshev rule. And like, you do want to be well organized, so that way, once you get to those type of problems, you know exactly where you are. You shouldn't take minutes being looking through your notes to find it. Like everything should be at your fingertip, and like you should be able to find it in less than like 30 seconds. So do try like get everything organized so that way, once those type of question does pop up, you can easily go to the notes, see what you need to get, and then be able to do that problem. All right. Let's see. Any question in regard to five number summary? All right, here, let me go back to my. Let's see. I'll answer that question at the end. Let's see. Any question in regard to five number summary or outlier and box plot? All right, what question do we have? Sure. Let's do a five number summary. Cool. All right, so we'll go over outliers. And find number summary. Cool. I should put an outlier in this problem. All right, so here is my data set. Before you even begin the problem, you should kind of already know there's an outlier. 50 is the outlier. But we're going to do this mathematically and show why 50 is an outlier. So first thing we're going to go ahead and do, we're going to go ahead and find the find number summary. So let's cross, 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 cross. All right. So we get our medium is 9. So our medium is 9. So now we're going to go ahead and we're going to get quartile 1. So quartile 1 is the left-hand data set. So you cross, 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 cross. Cool. That's quartile 1. So you get 2. Now I want to get quartile 3. So quartile 3 are the number to the right of 9. So we cross, 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 cross. And that's 20. Last thing we want to do, we want to get the max and the min. So the max is 50. The min is 1. And that's your 5-number summary. So if you're looking at the 5-number summary, it shouldn't take you that long to do, as long as you know how to find the 5-number summary. If you're struggling on a 5-number summary, then like it could take you like 30 minutes to 20 minutes or 40 minutes or so on and so forth. So you do kind of want to practice on this to make sure that you really understand how to do the 5-number summary. Any question for the 5-number summary? All right, let's do outliers. So for outlier, first thing you want to go ahead and do is find the IQR. IQR, you get the quartile 3, and you subtract it by quartile 1. And yes, they do have to be in order, because if they're not in order, then you just have 5 random numbers. Anytime you're finding the 5-number summary or the medium or quartile 1 or quartile 3, they always have to be in order, because if they're not in order, you're just finding 5 random numbers. So it wouldn't make any sense. All right, so IQR is 18. Well, no, well, for the IQR, you're going to use this for the lower fence and for the upper fence. Q1 minus 1.5 times IQR. Q3 plus 1.5 times IQR. So that's why you need the IQR. You have to find the lower fence and the upper fence. So for the lower fence, let me change the color of this. You get Q1, which is 2, minus 1.5 times IQR, which is 18. Let me work that out. So 2 minus 1.5 times 18. Go. All right, so you get negative 25. So negative 25 is my lower fence. My upper fence will be Q3, which is 20, plus 1.5 times 18. So if you do, 20 plus 1.5 times 18, and you get 47. Any questions so far? I got the lower fence or the upper fence? All right, so which number are outliers? Very good, fine. Perfect. Outlier is 50. So our outlier is 50, and that's how you find an outlier. You find the lower fence and the upper fence, and then you see, does your lower fence and the upper fence are all the number in between those values, or if all the value are in between the lower fence and the upper fence, you have no outlier. But if you have any number outside of the lower fence or the upper fence, then you have an outlier. All right, but that's it for the 5-number summary and for outlier. Any question in regard to the 5-number summary or outlier? For this, are we going to have to show our work? Ooh, all right. Cool. Thank you, Julie. All right. So for the first question about for the test, are we going to have to show our work and upload picture, or do we just plug in the number? If you want, you can just plug in the number. I don't really care. That's why I taught you how to do it in the calculator. For problem I tell you to do it by hand, like you will have to do it by hand, and that's the one that you're gonna have to upload picture if you're doing it by hand. But if it doesn't mention anything about doing it by hand, you can just assume that you can just do it with the calculator. And yet the 1.5 is part of the formula because if you look at the lower fence and the upper fence, it's just a constant number that they chose. So yeah, so it's part of the formula. And correct, yeah. If I'm just asking for the 5-number summary, all you have to do is give me the 5-number summary. The IQR is not part of that 5-number summary. The 5-number summary, well, sorry, the IQR only comes into play when we're finding the outlier because you need the IQR for the lower fence and for the upper fence. So that's why we found the IQR. Perfect. All right, sweet. Any other question in regard to the lower fence or the upper fence? All right, let's go back to this. All right, let's see. Let me get this. All right, any question in regard to how to find the range? All right, no range. Z-score, just look at what we did for the Z-score for the quiz. Pretty much that's what you need to know for the Z-score for the quiz. Just look at the quiz and you should have it. So range is larger than, yeah, good, yeah. All you have to do is get the biggest number, subtract from the smallest number, and that will give you your range. Yeah. All right, last one, calculate the mean. I already did the standard deviation by hand. Technically, I already did the mean by hand because when I calculate the standard deviation, we also needed to do the mean. All right, the dot plots, well, the dot plot represent a graph. I don't know what do you mean by what does it represent. All right. So any other question in regard to anything on the study guide? All right. So pretty much just know for the exam. So the exam you're gonna have 90 minutes of this first exam. The first exam should be the easiest exam because it's only gonna get harder from here. Because once you see what we go over tomorrow, chapter 4 is gonna be a little bit more. Well, it's gonna be a little bit more detail and more calculations to do for that one. So you kind of want to get a very, very good grade on test number 1 because test number 1 should be the easiest and it should be the highest grade. So for this one, you don't really want to take it lightly and you think like you don't really have to study for this one or have notes for this one. Because if you do take it lightly, it will pretty much like you won't do good on this exam. So do study for this one, prepare as hard for this one because it's only gonna get harder from here. So do your very best on this first one because, like I said, it's only gonna get harder from here. So do plan out your notes. Do have everything organized so that way you're not really fumbling around and losing valuable time. Because the time you're not gonna have that much time that you can just take like 10 to 15 minutes on a problem. If you take 10 to 15 minutes on a problem, that will absolutely kill your chances of doing good on the test. So yes, make sure like you have open book, you have open notes, like everything should be at your fingertip, and like you should be doing very well on this first exam. All right. Any question in regard to study guide? All right. There are some, but they're very few. Like I don't know exactly how many are multiple choice. Of the 39, I would probably say I don't know, like 9 of them are multiple choice. Maybe 9 of them. But I don't really know how many are multiple choice. Like the multiple choice will probably be like discrete or continuous, observation versus experiment, categorical versus numerical. So like stuff like that. Like, but for like chapter number 3, none of them should be. None of them will be multiple choice. It will pretty much be like you saw this last quiz where you have to just enter numerical values. All right. So let's do a poll. So let's see, how ready are you for the test? And this is anonymous, so I don't know who's saying what. So take this poll. Cool. All right, so let's see, let's end poll and let's share the result. All right, so 25% of you are ready, 20% of you are almost ready, 5% of you are not ready, 35% of you are, I am not ready, but should be by Monday. All right, and 15% of you need a miracle. That's not good for the first test. So if you do need help, like I do have office hour. If you have questions about anything that we go over or any problem on the notes or any problem on homework, do show up to the office hour. I also gave you the thing about for tutor, like if you can try seeing if you could see Juderay. I think you do Tuesdays and Thursday, if I remember correctly. So try see if you can set up an appointment with Juderay to try to help you out with this. But if you need a miracle right now, that's not looking good. So do try to come to my office hour so that way I can kind of help you out and see if we could get you to I'm ready or almost ready for this test. Stop sharing. Right. Any other question before I pretty much end the meeting? All right, so there's no further question. I'm gonna end the meeting. So just remember for tomorrow we're gonna get started with chapter 4, and chapter 4 is not gonna be on the test. So anything we go over on Wednesday and Thursday, none of that you have to worry about for the test because none of that will be on the test.